David Carbine Williams, perhaps the only gun designer that's ever had a feature-length movie made about him, starring Jimmy Stewart, had actually killed a deputy sheriff during a run on his still in North Carolina. A little bit of controversy whether he actually pulled the trigger or one of his associates, but anyway, he was sentenced to 30 years in prison and hard labor, and eventually got commuted down to about 9 years he served. But while he was in prison, he actually worked out the fundamentals for what became the foundation for the M1 Carbine.
Welcome back to the Weapons Locker. Today we're taking a deep, no-nonsense look at one of the most misunderstood U.S. service weapons of the Second World War, the M1 Carbine. This wasn't a battle rifle, it wasn't a submachine gun, and it was never intended to replace the M1 Garand. The M1 Carbine existed because the U.S. Army identified a serious problem early in the war, and pistols weren't cutting it. By 1940, a massive percentage of American troops were being issued sidearms as their primary weapon. Radio operators, vehicle crews, mortar teams, medics, engineers, officers, and rear echelon troops often went into combat zones armed with little more than a handgun. Handguns are difficult to shoot well under stress. They require constant training to maintain proficiency, and their effective range is extremely limited. The Army didn't want to burden these troops with a full-length infantry rifle. They wanted something lighter, easier to carry, faster to train with, and significantly more effective than a pistol. That requirement gave birth to the M1 Carbine. From the very beginning, the carbine was designed around portability and controllability. Mechanically, it is a gas-operated weapon using a short-stroke piston system paired with a rotating bolt. This is a key distinction because unlike long-stroke systems, the piston only moves a short distance before transferring energy to the operating slide. When the rifle fires, gas is tapped from the barrel and drives the piston rearward. That impulse moves the operating slide, which cams the bolt to rotate and unlock. The bolt then travels rearward, extracting and ejecting the spent casing. As the recoil spring pushes everything forward again, a fresh round is stripped from the magazine, chambered, and the bolt rotates back into lock. The result is a smooth, low recoil cycle that's easy to control, even for inexperienced shooters. This operating system mattered because of the weapon's role. The M1 Carbine wasn't meant for sustained fire at long range. It was meant to be carried constantly, brought into action quickly, and fired accurately under stress. That philosophy is reflected in its size and weight. The carbine uses a 17.75-inch barrel and measures just over 35 inches in overall length. Unloaded, it weighs a little over 5 pounds, nearly 3 pounds lighter than an M1 Garand. That difference is enormous when you're climbing into vehicles, moving through dense terrain, or carrying a radio, medical kit, or heavy equipment alongside your weapon. Standard magazines initially held 15 rounds, which was considered generous at the time. Later in the war, 30-round magazines were introduced and became common, particularly with select fire variants. Muzzle velocity averages around 1900 feet per second. That puts it well beyond typical pistol calibers and most submachine gun rounds, while remaining far more manageable than full-power rifle cartridges. This balance between weight, recoil, and performance is what defined the M1 Carbine. That brings us to the .30 carbine cartridge itself, another source of endless debate. The .30 carbine round occupies a unique middle ground. It is neither a handgun cartridge nor a traditional rifle cartridge. Compared to pistol rounds, it offers dramatically improved velocity, range, and penetration. Compared to rifle cartridges, it is lighter, softer shooting, and easier to control, especially in rapid fire. It was never designed for long-range marksmanship, trench warfare, or bayonet combat. It was designed for practical combat distances, where speed, handling, and hit probability mattered more than raw power. Within those parameters, it performed exactly as intended. The standard M1 Carbine was semi-automatic and relatively simple in configuration, but wartime realities quickly drove the platform to evolve. One of the first major variants was the M1A1 Carbine, issued primarily to airborne forces. This version featured a side-folding metal stock, allowing it to be carried more compactly during parachute jumps and maneuvered more easily in confined spaces. Internally, the M1A1 was identical to the standard M1. The difference wasn't firepower, it was mobility. For paratroopers, that mattered. As combat intensified, especially in close terrain, the need for higher volumes of fire became more apparent. That requirement led to the development of the M2 carbine. The M2 introduced select fire capability, allowing the weapon to operate in both semi-automatic and fully automatic modes. Contrary to popular belief, many M2 carbines were not newly manufactured weapons. Instead, existing M1 carbines were converted using military-issued conversion kits. These modifications focused primarily on the fire control group, adding components that enabled automatic fire while reinforcing areas subject to increased wear. With 30-round magazines, the M2 became a highly effective close to mid-range automatic weapon. As the M1 and M2 carbines continued to evolve, the U.S. military began experimenting with something that, at the time, felt almost like science fiction. The result was the M3 carbine. The M3 was built on the M2 platform and designed specifically to mount an early active infrared night vision system. Unlike modern passive night vision, this system relied on an infrared spotlight paired with a specialized scope. The operator illuminated the battlefield with invisible infrared light, and the scope allowed them to see reflected signatures in near total darkness. In 1945, this was revolutionary. While production numbers were limited and the system was bulky by modern standards, it represented one of the first real attempts at giving infantry forces a true night fighting capability. The M3 carbine wasn't just a weapon. It was a proof of concept that would shape the future of warfare. But the story of the M1 carbine isn't just about design or battlefield use. It's also about manufacturing on a scale the United States had never attempted before. Unlike most military firearms, carbine production was deliberately spread across a massive network of civilian manufacturers. Some of these were traditional firearms companies. Others had never built a weapon in their lives. Companies like Winchester Repeating Arms handled production alongside firms such as Inland Division, which ultimately became the largest single producer of M1 carbines. But the list didn't stop there. IBM produced receivers. Rock-Ola, yes, the jukebox company, built carbines. Underwood Elliott Fisher, best known for office equipment, turned out thousands of rifles. Automotive divisions like Saginaw Steering Gear were also deeply involved. This wasn't a mistake. It was a deliberate strategy. The U.S. government demanded absolute interchangeability. Every bolt, every barrel, every trigger group had to fit and function across weapons produced by entirely different companies. A bolt made by IBM had to work in a receiver made by Inland. A barrel produced by a jukebox manufacturer had to fit a rifle assembled by an automotive plant. This level of standardization was unprecedented, and remarkably, it worked. Because of this, post-war arsenal rebuilds freely mixed parts from different manufacturers. Carbines were upgraded, repaired, and reissued without regard for original factory configuration. This is why most surviving M1 carbines today are parts mixed. That's not a flaw, that's history. A perfectly matching M1 carbine is actually less representative of how these weapons served than one rebuilt and reissued multiple times. Another commonly misunderstood aspect of the M1 carbine is its reputation in later conflicts, particularly Korea. Cold weather exposed weaknesses in ammunition quality, lubrication practices, and maintenance, not necessarily in the design itself. When properly maintained and fed quality ammunition, the carbine continued to serve effectively, even in harsh environments. Context matters. Weapons don't exist in a vacuum, and neither do the stories told about them. So why does the M1 carbine still matter today? Because it represents one of the earliest successful implementations of a lightweight, intermediate power service weapon. It challenged the idea that every soldier needed a full-size rifle. It demonstrated how smart engineering could reduce weight without sacrificing effectiveness. And it proved that massive civilian industrial networks could be mobilized to produce reliable military hardware at scale. The M1 Carbine served in World War II. It served in Korea. It served in Vietnam. And it continued to appear around the world for decades afterward. It wasn't perfect, but it was adaptable, practical, and exactly what it was designed to be. The M1 Carbine is not a myth. It's not a meme, and it's not a failure. It's a case study in wartime engineering, logistics, and necessity. And that's why it deserves its place in the weapons locker.